adding the search text. Review design first. So in this section, we are going to add a search bar component with a search text field for now. Later we add another element to the search bar. This is search text field, and for that we create an interface iSearch bar events with an onSearch text change string. Note that the type of the parameter is string. Interface functions should be generic and serializable as much as possible. Here, the app component doesn't care the details of what machinery the search component uses to deliver search texts. The other type we need is the tSearch bar props. We are going to define a search text string properties. So in this design, the search bar is not going to have state at all. All data are coming from the master, the parent component, and all modifications, state changes are pushed up or triggered up to the top level component. This is exactly in sync with the thinking in React specification or the documentation. This is the official way the designers of React wanted us, the developer, to implement application with the React concepts of props and state. So when we have the search bar events interface with the onSearch text change function definition, this is implemented by the application logic component, the app component, which in this design is called Pixabay Image Finder. And here, this is the onSearch text change. Okay, I change it here. What is important to note that this is the correct way of implementing it. It's async since it calls the async query images from Pixabay, just like in the component did mount. Back to the search bar, it creates a text field, and when being rendered, it simply links the value property of the text field directly to the props search text received from the app component, like so. When the user enters text, for each change, the onSearch text change is called. So the next step is to implement the search bar with Material UI. According to the specification, let's write an iSearch bar events interface definition. Let's do it here. Interface iSearch bar events, and then onSearch text change search text. It has one argument, string argument, okay, and it should be void as a return type. Okay, that's all. Next, we are going to extend our Pixabay Finder state. We come up back. This is the Finder state. You can add search text string, and immediately VS Code jumps in that we have to extend the initialization of the state with search text an empty string. Next thing, which is important, that as I explained, this application component is going to be responsible for handling the search text modification. So we are implements not Pixabay, but search bar events interface. Of course, we have received the error message that we declare that we are going to implement this interface, and we should implement it. We are in a very lucky situation because this search exchange is going to be public, very similar to, we don't have any error right away because this is just a void, so when we don't do anything, so we are completely fine. However, here let me just use a different syntax. This equal, this is going to be an async function, exactly the same as the component did mount. Of course, void is not valid anymore because this is implicitly this async. Okay, so this is a nice example that even a lambda function definition fits perfectly fine with this traditional function definition syntax. This is very cool from TypeScript. So here what we are doing is very similar to this what we did in component did mount. First we set the state for the search text. This set state search text. Because this comes from the search text, we can use the shorthand format. So this is one step. And then remember, this is an asynchronous function. At the next one, we are going to call the Pixabay API, but at this moment, we are not doing with this fixed docs. We are using the search text that we received as parameter. More or less, we are done. Practically, we could try it. However, this function is not called at the moment. So therefore, we modify the component did mount to invoke this on search on text change, just for fun. So let's just comment all this out. So one async function is calling another async function. So what we should do is await this on search text chain and initially docs. Let's just invoke that function. So this way we simply reuse one of the function which is later going to be used by the text search component, the search bar component. Okay, let's give it a try. npm start, compiling again. Excellent. The next step is to implement our component, the search bar component. Before doing that, we need, according to the design, a props type. Search bar is not going to have its own state. It inherits all necessary data for their work from the parent component. So that's why it requires only a props type. And this is going to be type t search bar props, and only one field, search text string. We can simply copy it from here. This is another common pattern that the top level components passes down copies of their states to the child components as props, read-only props. So this is what we are following here. So when we have this very simple type definition, we can start implementing class. Because we use Props only. We could also use functional components either. It really doesn't matter, it's up to you. But for here, based on my design, I use the classes. So class search bar extends React component, and then comes our T search bar props definition. And then the only function it's mandatory here is a public render, okay, which return the typical components. Before we continue, this is not the only type we have to define here. We also need the interface functions either, because the onSearchTextChange function we should from the search bar should be called back in the application. How can we do that? Simply and search bar events. We add this here too, and then immediately we have it either. When we come back to the up bar and enter search bar like so, we have an error message that it requires search text and an onSearchTextChange. So therefore, Ctrl Shift, first the search text, which comes from, in our case, this dot state dot search text. The second component is onSearchTextChange, which simply this dot onSearchTextChange. This way we linked our search text state field, the parent component, down to the search bar component. Then also the parent component, the application logic component, passed down a handler function as part of the iSearchBar events interface down to the search bar component. Now it's really the responsibility of the search bar to display the actual search text, and whenever the user changes the search text, this text should be called back and triggered back, sent back to the parent component via this callback function onSearchTextChange. I can see here immediately a typo. Let's fix this typo. To see, not here, sorry. It's in the interface definition. Yeah, it's here. It's not text, but it's text. And immediately we seen that we have to change it here because this field is not good anymore. Search text, search bar is okay. However, the application is not okay. The reason is that because this onSearch is renamed, so we have to change accordingly. Then it has to be changed, so we have to change it here too. Of course, we could apply search text. Excellent. And we still have one error here. Brilliant. So this was by mistake a brilliant demonstration why we love TypeScript and type-safe programming. Most typical bugs are because of these typos and of course a missing design. We have the design in place here, so we need then the tool to help us for nice implementation of our application, at least to avoid the most typical, the most blatant and annoying programmer's error. The next bit to implement the search bar component. For here we need a text field. So what I did was I just used some of these examples from the Material UI text field demo, and then I worked with some of these examples, and I was interested how it would be implemented, applied in my example. So what I have done is not my own. I used heavily this example. So let's first import Material UI components. I split editor up. And just copy. So we need a text field. Yes. Okay, and we also need a input adornment. Input adornment. For this application, we have here a text field. We have a label with a text search and a value. Here we can use, of course, the prop, the parent, this dot props dot search text. This is what we are going to display. What else do we need? I defined here a style. Here I defined a margin top 8. Then another interesting thing is the input props, which is and adornment, input adornment, position, and okay, here we enter we need a search icon too. Just import search icon, import text from Material UI icons / search. I don't have here. Search icon, put adornment. Yeah, and we need also help text, start typing search string, full width, and this is it. Yeah, only one text field, quite complex, but most of them are just styling. That's the responsibility of the search bar. This is how it looks. Let's save it to see if it's displayed correctly. Excellent. And immediately we can see that because we set with the search application the parameters. Yes, at the moment it doesn't do anything because the most important thing one of the most important function is not done. The callback function for the onText change is not linked, but the rest, okay. Come back and then finalize our tutorial. Here we just add on change, and now comes a trick. Because we have to call back the search string, I use here a simple lambda function to call back parent, that is this dot props dot on search text change. Then it's going to have a parameter search text, and it is coming from the e dot target value. This should work. I think that's all. Of course, we can omit this parentheses, but I love this because at least one slight notification that we are defining a lambda expression here, which we can also I can enter a warning here. In TypeScript, there is in tslint, there is a rule that lambdas are not allowed in JSX. Don't use tslint here in this example, and that's why hopefully it's not going to complain. I saved it, compilation done, coming back, dogs. Oh, it works, and we can see that great. This is how it works. For completing this tutorial, let's compare this of our solution in React sample. This is in step 5. And filterable product table. This is the parent component, which is the same as our app component, has its own handle filter text change, as seen here, handle text change. So, and then it simply sets the state to filter text, like so. So this is exactly what we are doing in our application component on search text change. We set the state. One interesting thing, let me just explain to you. Set state is async in React. Also, our Pixabay query image from Pixabay function is async, and this is async too. All the three functions are called asynchronously. Unfortunately, this is perfectly fine because none of these function call depends on the previous state of the change. So this set state just depends on the incoming value that came from the guy who typed the text, the search thing. So that's the first step. Then exactly the same search text, we start at the same time parallel. Practically these are executed parallel with the search text, but because we have an await here, this third line is not executed until we have the images. Of course, the rest of the application is going along, but this part of application is blocked, but the application is not blocked. That's asynchronous, that's async await programming. So when we have the images, we again set the state, and then we set the images as well as the error message to back to default value. We are coming in the original example to the search bar. Here is the search bar. Search bar in this example is called with the filter text. You see, filter text is passed down from the state of the parent component, state filter text. This is how it should, that's the React way. That's how these guys at Facebook or wherever invented the whole concept. They also pass down the filter text change event handler, handle filter text change. And the handle, this is the function that they are passing down as a callback function. And the search component, here's a search bar in their example. It was very interesting that I implemented my application the way I did it, and later I found this article, and I was so much surprised that practically this way of thinking in React is exactly the same as normally we mobile application developers are doing it for about 5 to 6 years now. So we have exactly the same structure or very similar structure, but of course we didn't use in my application, I didn't use web technologies, we used Android, but the concept was very similar. Android and Windows CE. Anyhow, so when in the search bar has the properties, these guys are fighting with this binding, which is a bit faster than the lambda expression I used. Anyhow, it's really up to you if you prefer this binding style or the lambda expression way as I've demonstrated here. So this is my preferred way. That's why I added here this comment. This is a possibility for performance improvement. If someone believes firmly that this binding gives a really big performance boost, all of these parts can be replaced with this binding style. Then in the input field, the on change, it passes along the filter text from the props as well as a filter text change. The trick here is this guy is doing, because he doesn't use a lambda expression here, he had to define a local function, handle filter text change. So, and then when this local function, a member method is called, then it propagates, calls towards the prop callback function, props with the target value, which is the search string. Exactly the same structure. This is what I call the thinking in React, just coming from from an official article from the reactjs.org. Okay, and the last step is to apply changes. Do the changes before committing. Everything important happened in the app.tsx. App.tsx, we imported the text field, imported order search icons for the search bar implementation. Wayfinder state, that is the application state, has been extended with an error with the search text string field. Application class extended an implementation implements iSearchBar events. Search bar events from here. So it's very nice. It's that you can define an interface after it has been referenced. It has only one function. Function was implemented here as a style, an asynchronous, very important because it's going to call an asynchronous query function. I explained it a lot, and then I also, because this looked very similar to the component it mounted originally, we simply called this on search. Okay. Yes, so this is the simplified way. I just remove this comment. We don't need that anymore. So we populate our application with dogs as we used to do before. If the user later wanted, they had the chance to change from dogs to something else. We implemented the search bar events and as well as the search bar props, an interface with functions and a type for structures. I think it's not necessary to separate these, but the reason I did is that because when I implemented this differently, because this interface was required for the application here, because the app implemented this part. And then the T search bar props was only required for the search bar. I kept in a separate type definition, an interface and a type definition. And fortunately in TypeScript, this fancy syntax, T search bar props and I search bar events, it's a concatenation of the fields from both of them. So that's why in the search bar, when we used this component, we had to define both the search bar for search text as well as from the state, as well as the on search text change, the function, the callback function to handle the modifications. And then the rest was just the implementation of the search bar with labels and the value coming from the this.props.search text. And the on change is a lambda expression where this event handler is calling back the on search text change from the parent component. Commit our changes, search bar with search text field fronted. Okay. Excellent. Search bar with search traffic added.